Welcome to my projectbazaar.com. Let us see demo for Honeybee behavior inspired load balancing of tasks in cloud computing environment. In abstract, load balancing of non-preemptive independent tasks on virtual machines is an important aspect of task scheduling in cloud. Whenever certain VMs are overloaded and remaining VMs are underloaded with tasks for processing, the load has to be balanced to achieve optimal machine utilization. In this paper, we propose an algorithm named Honeybee behavior inspired load balancing, which aims to achieve well-balanced load across virtual machine for maximizing the throughput. The proposed algorithm also balances the priorities of the task on the machine in each way that the amount of waiting time of the task in the queue is minimal. We have compared the proposed algorithm with existing load balancing and scheduling algorithm. Our proposed illustrates that significant improvement in average execution time and reduction in waiting time of the task queue. The specific contribution of this paper include an algorithm for scheduling and load balancing of non-preemptive independent tasks in cloud computing environment inspired by Honeybee behavior, a literature survey about various existing load balancing algorithm and the merits and demerits of this technique, correlation of the proposed HBBLB algorithm, that means Honeybee behavior algorithm is actual foregoing behavior of honeybees using the clear flow diagram showing the behavior control structure of honeybees and Honeybee HBBLB, an analysis and systematic study with mathematical evidence to show how the Honeybee behavior inspired load balancing on work for cloud computing environments. Performance analysis of proposed algorithm and an evaluation of the algorithm with respect to other existing algorithms. So first we have to create a cloud environment. Cloud environment is nothing but it is a combination of data center, cloud broker, virtual machine and cloudlet creation. That means we can create the job, it will allocate it to broker and broker is allocated to particular VM and VM is running on the under DC. That means we have to consider the VM bandwidth, RAM size and VM size and initialize the file size, output size and length of the cloudlet are initialized. Then after initializing, create a cloud environment for final procedure. After that we have to load the VM. Which is nothing but scheduling and load balancing. The service request from the client or deserve application can be routed at any data center by to end server in the cloud. The routing of service request to the reserve server is based on cloud management policies based on load of the individual server, closeness to database. Two frequently used scheduling principle is in a non-preemptive system or the first in first out and weighted round robin policies. These policies may end up with different degrees of loads on each and every VM. This may lead to load difference between VMs computing in parallel. This creates additional problem of reduction in response time, wastage of resources, load balancing decision after finding the workload and standard deviation. The system should decide whether to be load balancing or not. For this further we can finding whether the system is balanced or otherwise it will be maximum loaded. After we can analyze the maximum and minimum loaded jobs, we can predict the load using this algorithm. That means maximum and minimum algorithm is used to predict the load. That means we can divide the jobs, maximum job and minimum job. That means first of all we have to give the job to VM minimum job, that is VM will not overloaded, but we have to give heavy loaded job means VM will overload. So maximum algorithm used to find out the minimum and maximum jobs and finally predict the load prediction. After that we can give the VM to the corresponding jobs. Let us run our project. First we have to run the framework.java, the Honeybee technique using maximum load optimization cloud environment, and after we have to clicking the job. In this project we have to use the cloud sim tool. The cloud sim tool is nothing but it will be create the data center, broker and virtual machine, and cloudlet easy to create. In our real time it is difficult to create the data center, virtual machines and broker and cloudlet. Using cloud sim tool it is easy to create jobs, broker, virtual machine and data center. In this project it is a main thing to create a cloud environment. First of all, we have to create the number of data centers. 2 data centers we have to create it, and another step we have to create the number of brokers. 5 brokers are we have to create it, and we have to create the virtual machines. 7 virtual machine we have to create it. Next, we have to create the cloudlet creation. Number of cloudlet is 10. 10 cloud jobs are created. In this place, we have to clearly know about the cloud environment. In the cloudlet creation, that is nothing but it is a job. This job will be given to the broker, and broker is given to the virtual machine, and finally the virtual machine is placed on the data center, and this virtual machine will be process these jobs as all jobs as. Predicted information means load analysis, load calculator successfully. Each and every virtual machine, it will be execution time for each jobs. And next, cloud allocation. Allocation means view. Each task is this data center ID is 0, and we have to check the VM group allocation. VM group allocation is nothing but we have to success state only. We have shown the success state of the jobs. Finally, we have to find out the maximum loaded jobs. Next, and we have to find out the minimum loaded jobs. And finally, using max-min algorithm, we have to predict the load prediction. And view the project and performance evaluations. Thank you.